Hey guys, welcome back to another problem solving tutorial. And in this tutorial I'm going to be showing you guys how you can solve Leetcode problem 128, longest consecutive sequence. So the problem is basically asking you to return the length of the longest consecutive elements, so the longest streak of elements which are all consecutive basically. And the reason this is slightly challenging is because the list is actually unordered, so it's not as simple as just starting and then seeing how far you can go, because the list is unordered. So you can see in this first example, the longest streak is of length 4, and it starts from 1, then jumps to 2, 3, and then 4. So yeah, now the method to solve this is relatively simple, and the way we like to think about it is we want to start from the bottom of the streak and then just work our way up and see how far we can go. So let's do something like this. So let's just remember this array: 100, 4, 200, I think it was 132. Okay, so what we're going to do is it wants us to do an O of n type, so that means we can't sort or anything like that, because that's going to be O of n log n, like that, and that's that's actually greater than O of n, so we don't want to sort this. What we want to do is we want to use linear, we want to iterate through it linearly, and we'll start here, and basically for each item we want to like determine whether it's the bottom of its streak or not. We want to determine if it's the minimum item in the streak, and to do that what we do is all we need to do is check if there's a number beneath this inside the list. So for 100, what we do is we'll check if 99 is in this list, and if it is, that means there's a number lower than 100 in the list, so therefore 100. There's a number 1 lower than 100, so therefore 100 isn't the minimum, since it goes 99, then 100 at least, so 100 can't be the minimum. And we're only interested in the minimum items of the streaks, so we just skip 100 in that case, if 99 was in the list, but it's not, so we know that it's technically the minimum. I'll skip that for now, but let's see. So let's go to 4, 200, and then let's say we go to 1, right? So we check for the item 0. 0 is not in the list, so therefore we can assume that 1 is the minimum of the streak, if there is a streak. Then what we do is we'd look for the next item. So we check if 2 is in the list, it is, so we go there. And then we check if 3 is in the list, it is, and then we check if 4 is in the list, and then we check if 5 is, but 5 isn't. So we know that this was a streak of length 4, and then we remember that. And that's basically how we identify streaks. So coming back to 100, we check if 99 is in the list. It's not, so technically 100 is also the minimum of its streak, if there was a streak. Then we check for 101, but that's nowhere to be found. So technically this has a streak length of 1. So that's the basic idea. We want to look for the minimums. And you might have also observed that there's a lot of checking for items if they exist. So what we're going to want to use is a set to get constant lookup times. So let's implement this quickly. What we can do is, first thing we're going to do is convert this into a set. So let's just say num set, and we can just do new set of nums. Then we're going to iterate through the set, so for const num of num set, and we want to check if it's a minimum. So check if num is minimum of its streak, if there is a streak. And to do that, we just do if numset.has num minus 1. If it does have it, then, so if 99 existed, that would imply that 100 isn't the minimum. So we know that if this is true, then nums isn't the minimum. So therefore, we're just going to skip it, and we can use continue. Num is not the minimum. Therefore, we skip it, because we want to start from the lowest item in the set, in the streak, and just work our way up to see how far the streak goes. If we try and do it from both directions, it's going to get complicated really fast. So we only want to work with the minimum item. So otherwise, if we get to here, we know num is the minimum of its streak. So now what we can do is we can just see how long the streak extends for. So let's just call this let streak length, and we'll start at 0. And I guess we'll just see how far we can go. So let's also create a variable called current num, set it equal to num, and we want to see, we're going to keep incrementing this and checking if numset has that number in it. So if numset.has current num, we're going to increment streak length by 1, and we're also going to add 1 to current num to then check for the next consecutive number. So imagine this was on 1, we'd check if it has it, if so it does, so adds 1 to streak length, goes to 2, checks it has it, adds 1 to streak length, check 3, add another 1, and then check 4. So currently streak length is on 4, then checks if 5's in it and 5 isn't, so it just stops that loop and we break out. So from here we have determined how far the streak extends for this particular num, which is a minimum, is a streak. So from here it's pretty simple. The questions ask us to find the maximums, so we can just keep track of what the greatest streak length was, and then we can just update it if we find one that's longer. Okay, here we go. And then we just can return streak length like so. So greatest streak length. Let's copy that in, and this should be all the code we need. So let's see what happens when we run it. Oh, okay, we get the wrong answer. Right, okay. Okay, so I'm not sure what's happening here. Let me just debug this quickly. Let's see, longest consecutive, and let's console.log streak lengths as we get them. Okay, so we're getting a bunch of 1s. Okay, I'm going to print the num as well. 100, so we get to 1, current num plus equals 1, current num, and also check if numset has this one, because I'm a bit confused why it hasn't continued past 1. So, okay, so, oh, I see what's happened here. This is meant to be a while loop, not just if. We want it to continue multiple times if like, we just want to see how far the streak goes. So we're going to go for as far as we can in a while loop, and then as soon as current num actually isn't in a streak anymore, this while loop's going to break. So that's what should have happened there. Okay, that was fine. And we'll just use while instead, and that should be the code we need. Just some quick debugging. Oh, wrong replacement, sorry about that. Okay, there we go. So we get a pretty good runtime. We have, okay, so memory's not too good, likely because we're just converting the whole thing to a set, so creating a whole new instance, but we're going to focus on a runtime. So it's being 71% right now, and we can actually make this faster using one line. What we can do is we can check if the streak length is greater than numset.length or .count. I think .size would also be fine. Yeah, so we're checking if streak length is greater than this numset.size divide by 2, if the streak length is greater than half the length of the list or set, then we know immediately that it's going to be the greatest streak, because you literally can't have a streak which is longer than it. If it's already taken up half or more, then no matter what other streak you have, it's just going to be the same or less than it, because there's not enough items left. And we know that no two streaks can intertwine, if that makes sense, because we're using the minimum of each streak, so we're getting the entire streak in one. So adding this one line in should allow us to fast return certain cases, which therefore should make our speed even faster. Let's see how this works. Okay, so yeah, we do get some slight improvements, beat 78.92%, and yeah, there's some decent improvements. Once you get into the 90s and 80s, that's pretty good. Honestly, to make this even faster, I think, yeah, there's not much we could do to actually make this faster, but sometimes you just gotta get lucky. So thanks for watching, and I'll see you guys in a future tutorial. Bye!